All right, we're going to go ahead and fill out a unit circle. Just as a reminder, a unit circle is a circle with a radius of 1. So, for example, at this point over here, it would be 1, 0, because it's going over 1, up 0. This length of this line is going to be 1. That means everything going around the circle, we would have 0, 1 here. Going to the left, we would have negative 1, 0. And then on the bottom here, it would be 0, negative 1. Now, I'm going to go ahead and fill in the degrees first, then do the radians, and then do our coordinates last. So, we're starting at 0 degrees, and we're going to go counterclockwise. 0 degrees, and I know, let's do our first upper half for our triangle, or right, our first upper half of our circle here. Half a circle is 180 degrees. Half of that is going to be 90 degrees. And then half of 90 degrees, which is right here, is going to be 45 degrees. Now, if I look at this 90 degrees is also split into thirds here. 1/3 here, 1/3 here, and 1/3 here. 1/3 of 90 degrees is going to be 30 degrees, which means 2/3 of it right here is going to be 60 degrees. And now I can just go ahead and add 30-degree increments for each one. So if I go 30, 60, 90, this would then be 120. This would be 150. Same thing goes with my 45. I'll have 45, 90, 135, 180. Then I'm going to go ahead and keep doing this pattern on the bottom half. I'm going to go do my 45s first since I just did that. So 180 plus 45 would be 225. 225 plus 45 would be 270. 270 plus 45 would be 315. And then going to fill out my whole circle, this would be 360 degrees. Let's go back up here and now do my 30-degree increments. So 150, 180, 210, 240. Again, we have our 270, 300, 330, and then 360. So our degrees now are all filled out. So now let's go ahead and do our radians. Again, we know a circle is 2 pi. I can go ahead and fill this in, 2 pi radians. So 0 degrees will also be 0 radians. Again, half a circle is going to be half of 2 pi, so that means it's going to be pi in radians for half a circle. And then half of that, being our 90 degrees, will be our pi divided by 2. If I want to go half of that again, that is going to be pi over 4 for my 45 degrees. And now let's go ahead and fill in our 30-degree increments, but now in radians. So I know that 30 degrees is 1/6 of 180. So I can just rewrite this first one here as pi over 6. And then I can now use this increment to fill in everything else. So pi over 6, 2 pi over 6, and 2 pi over 6 will simplify down to pi over 3, 3 pi over 6, 4 pi over 6. 4 pi over 6 will be the same thing as 2 pi over 3. Then I'll have 5 pi over 6, and then 6 pi over 6. So 1, 2, 3, 4, 5, 6. Keep going around. I will now have 7 pi over 6. Then I'll have 8 pi over 6. 8 pi over 6 simplifies down to 4 pi over 3. 9 pi over 6. 9 pi over 6 will simplify down to 3 pi over 2. 10 pi over 6, which simplifies down to 5 pi over 3. And then lastly, I will have 11 pi over 6, and then 12 pi over 6, which again is 2 pi. Now we'll do the same thing again, but we'll do it with our pi over 4. So pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4 or pi, 5 pi over 4, 6 pi over 4, or again, 3 pi over 2, and then 7 pi over 4. So that's how we go ahead and get our radians. So now our degrees and our radians are all filled in. Let's go ahead and do our coordinates. So our main focus here is I want to make sure we get down just our first quadrant, because after we get our first quadrant, we can go ahead and get the rest of our quadrants with reflections and stuff. So everything in between 0 degrees and 90 degrees will be divided by 2. So let's go put our 2's on the bottom here. I could go into detail here on how we get these points. However, that's what's special, right? Triangles being 45, 45, 90 triangles and 30, 60, 90 triangles. I'm not going to go into that here. If you're interested in that, ask me about that or look up a video, or maybe I'll make another one. Let's look ahead at our x values here. So I'm going from 1 to 0. 1 to 0 means I am going down. The numbers we're going to have here in our numerators are going to be 3, 2, and 1. Or 1, 2, and 3, some variation of that. We're going to go from 3 to 2 to 1, because as we see, if we're going from 1 to 0, it's going down. And then again, we're also going to put square root signs over the top of each. So root 3 over 2, root 2 over 2, and then 1. If you want to put a root over the 1 to keep the pattern there, that would work, because the root of 1 is going to still be 1. The same pattern is going to apply to my y values. I'm going from 0 to 1. So now I'm going from 1 to 2 to 3, and I'm going to go ahead and put a root on those 2. So that's just filling out my first quadrant here. Now, if we know a thing about our reflections, if I reflect this over my y-axis, the only thing that's going to change is I'm going to have a negative x now. So I'm going to take these same points. So I'm going to have 1 over 2, root 3 over 2, and I'm going to change this x value to be a negative. I'm going to repeat the same process for my other points now. So root 2 over 2, root 2 over 2, that's going to be a negative in my x. Root 3 over 2, 1 over 2, that's also going to be a negative in my x. I'm going to go ahead and skip quadrant 3 and do quadrant 4, because quadrant 4 will be a reflection over our y-axis. Not our y-axis, over our x-axis. So if I reflect over my x-axis, I'm just going to change my y values to be negative. So this is going to be root 3 over 2, and a negative 1/2 now. Root 2 over 2, negative root 2 over 2. 1 over 2, negative root 3 over 2. So again, now I'm just reflecting that across my x there. I changed those y values to be a negative. And again, if I reflect these ones now across my y-axis again, I'm just going to change my x's to be negative. So now in this one, both my x's and my y's will be negative. So negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, and then negative 1/2, negative root 3 over 2. And so now my whole entire unit circle is all filled out. And we can use this unit circle to go ahead and determine our special angles, our special exact angles of sine, cosine, and tangent, and we'll do that in a different video.